So I'll go. All right. So I've got 12:30 now. Sorry, local time here on the East Coast. I'm going to go ahead and start here. So I'm Dan Beavers. I'm the graduate program director at Wake Forest University, Department of Statistical Sciences. And what our next two speakers have in common is that they're both recent graduates of our master's program. We're a relatively new program. We just started as a department in 2022, although this master's degree came out of the math program. So if anybody has an interest in a master's in statistics, or if you know of any students that may have an interest, we would love to hear from you. We're advertising here. We've got a virtual open house coming up on October 23rd, and then an in-person on the 30th for those that are here in the Western North Carolina, Winston-Salem area. So, without further ado, I would like to introduce our next two speakers. First is Anh Nguyen. She's currently a visiting assistant professor here at Wake Forest, doing some great work with our students here. And so she will I'll actually just hand it over to you, Anh, to proceed with your talk.
Hi, thank you so much, Dr. Beavers. Yeah, so I was recently a graduate student at Wake Forest. I really enjoy my time here, and my talk today actually come from my survival analysis class that I took at Wake Forest. So we're doing a lot of fun thing here if you're joining us. Lots of cool opportunity. So this was from I had to do a final project for my survival analysis class. And I don't know about you, but I was feeling a Taylor Swift time to charting analysis when I talk about the project. So we all know Taylor Swift and the impact she has on the music industry. She is the music industry herself, started as a young country singer, but she was really special because she was the first one that really speak to teenage girl in the genre of country music. So recently she endorsed Cliṋahangers, and that drove like millions of people registering to vote for the upcoming election. She also have a museum that's going to happen in Virginia and Albert. So she is the music industry itself. Also, I am a self-proclaimed Swiftie. As you know, there is something that is going on called the Eras Tour. And the Eras Tours is really a chance for her and also her fans to revisit all of her eras. So for her, each era is an album cycle. And as you can see here, I have all of her album up for you to enjoy. She has a lot of albums. She released one roughly every 2 years. These are amazing. Why they are so different is that because, as you can see just by the album cover, each different album will have a different aesthetic. Also, in addition to the change in aesthetic, going from like country, something more folksy to something more edgy, it's also different in genre. We have country music, pop music, a little bit of electronic too. So she got it all covered. However, for our interest today, when we talk about era, we're not going to talk about each of her individual albums. We're going to talk about my demarcation of her era. So we have the first era to be her first 3 debut album. That's going to be her Taylor Swift debut, Fearless and Speak Now. The next two is going to be Red and 1989, which is when she veered into a more pop-centric sound. The next one is Reputation and Lover, which is when she has a lot more changes in her sound. And also we have the famous Snakegate incident. So for all those who are in the know, you know it. And then we have the pandemic era album number 4, which is the more folksy and more intimate album. And for all the fans out there, you already know that she has a special thing going on, is that she re-record her album. So we also have, for example, Red, that is the original, but we also have the re-recorded. So just to keep in mind, these are my grouping of the supposed eras, and these are pretty chronological. As you can see, we have from the debut up to her most recent album. And I'm just putting down little bars to separate where I think there was like a turning point in either her sound or her career. So can I ask you a question? these are the questions that I'm going to try to answer for you today. First thing is, what is the median time for charting for Taylor Swift songs overall? And the second question is, how does the charting time changes as she releases more albums? So that's also mean as she's becoming more established as an artist, how is this changing? We're going to do this by looking at data from the Billboard Hot 100, and we're also going to look at information for when the song is released and by looking at the Spotify song ID. Thank God the data was finally clean, so I didn't have to do a lot. And using these data, we're gonna look at the frequency count. So really just counting how many songs has charted or not. But however, to account for the fact that we do have a time varying variable here, we're gonna use the Kaplan-Meier curve. So the Kaplan-Meier curve is a very, if you take a survival class, that's probably gonna be the first model that you look at. This is to help us look at quantile for time to events. So this is an empirical model. And finally, because my eras grouping was just based on my personal opinion, I tried different grouping, sourcing from other Swiftie I know and on the internet to see if there's really a huge change in the result or not. Okay, so let's first look at did the song charted on the Billboard Hot 100 or not. So we use the Billboard Hot 100 because it counted the number of sales, either that be physical or digital. It also looked at how many times the song was streamed, either on Spotify or Apple Music or YouTube and many other places. It also looked at the number of radio play for the song. For me personally, this seems like a good indication of her popularity and how well she's doing with the general public. So looking at all of her songs across her entire discography, we see that a little bit more than 70% of her songs have charted, and we have something a little bit less than 30% of her songs that have not. That's a really big proportion of songs. But let's look at a little bit more closely with respect for each of her eras. Okay, so looking at our eras here and see whether the song has charted on the Billboard Hot 100 or not. Just a reminder for all of you, here's the number for each of the eras or chronological. So number 1 is going to be album that was closer to her debut, and number 6 is going to be album that was really just recently released. So we see here that for most of these eras, a lot of the song out of all 6 of the era that we have, 3 of them has more song that was charted than was not. For the other eras, there was more song that wasn't charted. That kind of makes sense to me for the era that have more song that did not chart it, because for number 5, we are looking at her re-release. So a lot of people might not want to go back and listen to those songs because it was already there. And for 2 and 3, those are her eras where the album is really, really long. So that's a lot of songs. And that just explains why we have more songs that didn't chart it. So all these different albums will have wildly different number of songs in it. Okay, so who's afraid of the little Kaplan-Meier curve? I love Kaplan-Meier curve. As you can see on your right here is a little example of what you can expect to see when we talk about Kaplan-Meier curve. So let's talk briefly about it before we use it for our Taylor Swift data. So on the x-axis, we have time, and here we're using weeks because the Billboard Hot 100 chart is updated every Sunday. So we really don't know what happened within the week. However, but we know that every week, every Sunday, new songs are going to pop up, and old songs are going to leave, or some songs are going to stay. On the y-axis, we have the proportion of songs that have not charted yet. So these are the songs that are still waiting for the fan to find out and listen to and get it charting. Here you can see that we have a lot of flat line. Those flat lines indicate that within that period of time, nothing is really happening. However, when we get to a drop, that indicate an event that happened. And for us, we are interested in whether her song has charted or not. So the drop will tell you that a song had charted, and the steeper these curves look, that means the song are charting at a way faster rate. If in contrast, if it's not that steep, that means it's happening at a relatively low state. So using this Clifford curve, we can find the probability of song charting beyond a certain time frame. So it's kind of like the cumulative probability, but like in reverse. Okay, but the one thing I need you to remember from this is just how steep our curve is going to be. So looking at all of her song, we can see that within the first 2 weeks, it's not that steep, but as we go a little bit beyond that, it drops immediately. That makes sense because usually she released the song on Friday, so it takes a while for her song to hit the chart. But on average, half of her song will have charted on the Billboard Hot 100 at around a little bit more than 2 weeks since the time of release. That's pretty fast, I would say. And you can probably still see that the curve keep going beyond 2 weeks mark. So we can see that there's more songs keep popping up. So that is for all the song. However, what if we do it for each era? If we do it for each era, then we can see that the era 1 and 2, so that's color red, and the little bit mustard yellow one is not that steep, but the most recent one, the purple curve for the most recent album, are super steep in comparison. So we can see that as she releases more album and establishes herself more, her time to charting really increased dramatically. As you can see, the median time for increases for era 6 is like a little bit more than 2 weeks, but the median time for the first 2 eras is a bit closer to being 3 weeks. I'll also show you every grouping that I've considered. So this is just an example of all the other grouping that I've considered because this grouping is pretty arbitrary. Here, I have taken the option to put all the re-recording into one era, which is number 3, and all the latest album is in number 4. And we can still see that with the more recent album, the time to charting is still much faster, as we can see in the steep curve that we have here, and the era for the other curve are not as steep. And it's really interesting that you can see a really huge drop. That means a lot of her songs just get up on the chart right away within that 2 weeks. So what did we learn about our charting time for our Queen Taylor Swift? We have learned that her time to charting increases when we consider her more recent album. That really makes sense. The more popular she is, the more sales and radio play and streaming she's gonna get. And what's really interesting is have a per song charted within 2 weeks of release. It would be really fun if we do the same thing for other artists to see if the median charting time is also the same. And really interesting thing is that for her most recent album, The Tortured Poet Department, all her songs charted. And that's all I have for you about Taylor Swift. Thank you, IDWSDS. These are the sources for my data if you want to have a go at it. And special thanks to Dr. Sarah Losbeach and Ashley Mullan for helping me with this presentation. Also Wake Forest, where I get to do this. And also Edward Kaplan and Paul Meyer for inventing this curve.
All right, well, thank you very much, An. Since we're about a quarter till the hour, I'm going to go ahead and move forward then with our next topic in the pop culture section. Our next speaker will be Ashley Mullan. She's also a Wake Forest master's grad and is currently a PhD student in biostatistics at Vanderbilt University.
Thank you so much for that kind introduction. And I don't know what was cooler, your results or your really clever Taylor Swift fun energy. So tough act to follow. I'm going to put this in full screen. Perfect. So my project is entitled For Better or For Worse, the First Kiss Effect on TV Ratings. And this started out as a little side project for WSDS as a poster last year under the advisorship of Doctors Sarah Lotspeich and Lucy D'Agostino McGowan at Wake Forest. And now I'm over at Vanderbilt University and presenting this in multiple forums. It also lives as a blog post on my website. And looks like I have to click into the PowerPoint for it too. There we go. And if you're interested in a copy of the slides, you can go to my website and follow along with a PDF. I'll give maybe 10 seconds for people to catch up there. And while you're doing that, I would like to reiterate the Masters at Wake Forest is a wonderful program. They gave me a great stepping stone to start my PhD, and I cannot recommend it enough. So additional plug there. All right, the four things we're going to talk about today are a quick crash course in Pop Culture 101, some of the methods I used to take on this project, some results, and a couple of takeaways if we happen to have any Hollywood folks in the audience. So first, we'll start with Pop Culture 101. So many television shows follow something that we call the will they or won't they trope, where the dynamic between a pair of characters is going to constantly shift. So we're going from almost romance to friendship to almost romance and back and forth. And this can be really, really annoying for the viewer because you never know if it's going to end up where you think it's going to end up. A couple like this is going to demonstrate romantic chemistry, but like I said, we've got uncertainty and conflict in their future, and we have no idea where things are going to go. For an example here, I gave Nick Miller and Jess Day from one of my favorite TV shows, New Girl. And I happen to know that they do end up kissing in season 2, episode 15, the last 9 minutes. But I only know that after a series of binge watching that. The viewer before that has no idea what's going to happen. Now, this concept is really cool because it's not exactly new. It doesn't just show up in TV and movies. It even shows up in some of the classic books. Like, for example, in the Austen book Pride and Prejudice, all the way back in 1813, we've got some of this dynamic. And then this pops up consistently in TV. For a couple of examples, I put Cheers, which debuted in 1982. We've got this popping up in Friends, which started in 1994. And of course, I couldn't leave out My Buddy New Girl. It's starting in 2011 and running for about 7 seasons. Now we've got 2 things that can go on here. If we're sitting here waiting for the couple's first kiss, and we were watching the producers delay this thing, there are 2 things that can happen once it happens. You can either do, I'll start with my personal favorite, the Ashley effect, where you see this episode, my case study would be season 2, episode 15, the last 9 minutes of New Girl, and you get excited and you watch all of season 3 and season 4 the next day. Spoiler alert, this did happen during the pandemic when we had time for TV binging. Or you can be in the other camp and exhibit the Zeigarnik effect, where you will be bored after this dramatic climax of the plot and quit watching. And this milestone of the first kiss can change the plot trajectory, influence the number of viewers of the show, and impact ratings, which we're going to use to quantify this effect. Now let's move a little bit more into the methodology. So to investigate this kiss effect, we're going to need some data. So after a series of internet trawling for BuzzFeed articles, Wikipedia pages, the like, we found 20 very popularly cited will they or won't they couples. And we scraped data about their ratings from IMDb, the Internet Movie Database, and Wikipedia for information about when they started. A couple of the things that we grabbed were the timing of the first kiss, the couple's popularity in number of mentions, the length of the show, the year of the show's premiere, and episode ratings from the start all the way to the end. Now, this is important because every show runs for a different amount of time. The classic example I give here is Shadowhunters, which is another one of these couples that only runs for 3 seasons, versus Grey's Anatomy, which I think is still going. They're at, what, season 20 now? So it's very important to think about how long these shows are doing when you're doing analysis. A couple of things to think about: love or exploratory data analysis at first sight. in our top 20 couples, we have over 40 years worth of TV going on here. We've got a couple of shows that started in the 80s, and they're a little bit more sparse here. And we move into a huge growth in this trope in the last 15 years between about 2010 and today. This is kind of cool that if you do it right, people are still going to be mentioning your shows about 40 years later. Now, another thing that I looked at is when are these kisses happening? Because I cannot say that I have seen every show in my data set, although I wish I was that cool. But I did check out relative to the end of the show when these kisses were happening in the show. And the key takeaway that I found here is that except in the 90s, the median first kiss of these top 20 couples happened within the first third of the show, which leaves plenty of room for either the Ashley effect of binging multiple seasons in one day, or the Zygarnik effect of getting bored to pop in after this kiss. Now, to move a little bit into the fancier analysis that we did, this lives in the realm of causal inference, and it's called an interrupted time series model. And what it does is it examines the ratings trend, but it specifically takes into account an interruption in this time series, particularly the couple's first kiss. And we look at how that affects the ratings. Specifically, we're going to quantify the trajectory of the ratings and how it changes after the first kiss. And there are actually two ways to fit this model. We can look at a show at a specific level. So for example, fit it to all of the episodes for New Girl. Or you can look overall and fit it to all of the data at once. And because we have a slight issue of autocorrelation going on here, we use the Nui West standard error to generate confidence intervals for these projections. And here's a quick sample of what this model might look like, and I'll move into interpretation coming up. So we have two questions of interest, and we're going to look at whether these ratings immediately change after the kiss, and that'll be beta 2. And to address how quickly the ratings return to the pre-kiss levels, if they ever do, we're going to look at beta 1 and beta 3. So that beta 1 is going to be the original episode-on-episode change before the first kiss, or the pre-kiss rating trend. Then that beta 2 is going to quantify the immediate change, which could look like a jump, it could look like nothing, it's attached to an indicator variable. And that beta 3 is going to map the difference in that rating. So the slope in the second part of the graph will be a combination of beta 1 and beta 3. And you'll see this a little more when we look at pictures. So let's look at the pictures. The first case study would be my personal favorite, Nick and Jess from New Girl. So we've got that dotted line in the top right, which is called a counterfactual. It's what we expect the ratings might have looked like if that kiss never happened. And we jumped from a little bit of an upward trend in the blue zone for the pre-kiss episodes, and we have a bit of a drop, it looks like, at least in the point estimate, after the kiss, which was personally really disappointing to me. But there's hope. After checking out the 95% confidence intervals, it looks like we can't really say if this trend is just a fluke in our particular New Girl. So let's look at another case study and see if we get a better answer. How about Ross and Rachel from Friends? Again, we look like we've got a steady increase in the ratings with that counterfactual going up and up and up, but it looks like it levels out after that kiss. But again, still hope for someone like me, an optimist. These confidence intervals are crossing 0 in most of them out to 3 decimal places, showing that we really don't have evidence either way for the Zygarnik effect or the quote unquote Ashley effect. Now I thought, okay, maybe let's increase the sample size, zoom out and look out to the 20 most cited couples and see if we can get a better answer there. Now this counterfactual looks a little bit less dramatic here. And unfortunately, we still do see, at least at the point estimate level, that these ratings are dropping. But thank goodness for optimists like me, we've got some confidence intervals crossing 0 at these changes, showing that we cannot say for sure whether we have the Zygarnik effect or the Ashley effect. So a quick summary, it looks like these ratings are dropping, at least in all of the examples that we looked at, but the confidence intervals don't give us quite the credibility to claim that this is for certain. And some takeaways for the Hollywood folks in the audience. Now, this is for the producers out there. Even these top 20 couples go back as far as the 1980s. So if you are smart and you pitch your show right, people will still talk about you 40 years later and maybe even do some statistics about you. And although these point estimates did look pretty dramatic, we actually cannot make a strong argument for either those that will binge 2 seasons in one day or for those that will get bored immediately, either at the show specific level or if you zoom out to look at 20 couples at the same time. So with that in mind, If you're a Hollywood person and you want to keep your ratings high and your viewers interested, you may want to consider pushing this moment a little bit, so you at least have some other plot content to cover before the kiss, or introduce another dramatic storyline. So much for love, right? And here are a couple of references. And I would like to thank Dr. Sarah Lotspeech and Dr. Lucy D'Agostino McGowan for helping me work through all of the nuances of interrupted time series. And thank you very much. And I think we have a couple minutes, so I could take a question or two if we have one.
Yeah, thank you very much, Ashley. So I'm not sure if I'm moderating or Cynthia, if you want to, but I think we could go to the chat for a handful of questions. I wanted, though, since I have this stage here, wanted to ask quickly about the Zeigarnik effect. How would one compare this to, for example, shark jumping? Is that similar? So for those folks that don't know, the idea of jumping the shark in a TV show means it's a reference to Happy Days, in which there was an episode in which they literally jumped over a shark and the ratings went down from there.
So I have not seen that show, but
Yeah. Have you heard of the
to answer
expression
your
jumping
question
the
with a
shark?
question, was this something that they were building up to, or was this something just happened out of nowhere?
Yeah, no, that was kind of out of nowhere, I believe. I don't know. I'm not.
So, Ken,
I
I
think the
don't think we're
broader.
looking at quite the same phenomenon here. The
Okay.
idea of the Zeigarnik effect is that there's all of this drama, you're watching, and then it's like all of a sudden the storyline is over, and then you get bored and go find another show.
Yeah, okay, that makes sense. So an actual statistical question, there's a comment about, can you elaborate a bit about autocorrelation and how you addressed for it?
Sure. So the idea is that this is some sort of time series type thing because every episode comes in a series. And we noticed that there was a little bit of trouble with the coverage of these confidence intervals. So we specifically looked at the new US standard errors to adjust for that with the bar intervals.
Thank you. Also, for folks that have questions for On as well, please chime in here as well. So there's a comment about the I guess the list of the top 20. I guess more broadly, where'd you get your data set?
For me,
For
we
Ashley,
did a
yes.
lot of Googling of will they, won't they couples. This was something that Dr. Sarah Lotspeech was also really helpful with. And if a couple was mentioned on the internet, they were added to our spreadsheet. And this is something that actually we do have a DOI for. So if you Google this project, there will be data available for that. Ooh, and it looks like the DOI was just dropped in the chat. So if anybody's interested in playing around with it yourself, I encourage you. And maybe you'll find a new show you like out of it.
Are there any other questions right now? So these are very fascinating topics. I do wonder if there exists a database of shows to use as controls in this situation. So, for example, that didn't have some sort of plot element to build up to. I apologize, Anna. I'm sort of focused on this pop culture TV show topic right now.
I mean, I would think we could potentially do it with some kind of matching, where there were shows with approximately the same length, similar plot type thing, but less of a rom-com type energy. Most of these were rom-coms or romantic dramas. The common element here is that every character pair in our data set did end up kissing on screen. That was our interruption in the time series.
Do you think other popular musical artists follow similar trends to Taylor Swift? Do you think something about this is unique to her?
Well, I know that she's really, especially now, she's like really, really good at like playing the chart, which is like get a lot of variants out, have a lot of little Easter eggs so that she can get her charting a lot faster. So that's why maybe we see such a dramatic chart. But like this is not to her only. All artists does this. So like people are like catching up and know how to play the game.
Okay. Well, unless there are no other questions, I might hand this over to the next group.
Thank you very much.
Yeah.